Hello and welcome to BEZ Talk with thought leaders in application of modeling. Today our guest is Dr. Salsburg. I know Mike for many years and he's a recognized leader in modeling. He spent many years working for Unisys, developing modeling technology, presented many papers at CMG. You're conducting workshops very successfully on applying modeling for performance management capacity planning. So I would like to take this opportunity, we're meeting at CMG, Impact 2017, and ask you several questions.
Let's do it.
So what are the secrets of successful implementation modeling to solving practical IT problems? What do you think?
I think the secret, as far as I'm concerned, is to not try to model too much. That the model has got to represent a specific request, or it has to answer a specific question. If you want to build a model that'll model your whole computer center,
just in case,
yeah, just in case,
yeah.
I think you're wasting your time, because by the time you finish whatever model you've done, the world has moved on. So you need to, first of all, have a real problem in front of you, build a model that focuses on answering that, and don't overcomplicate it. Keep it as simple as possible. Just focus on, well, you should focus on what you think will be the impact. So let's say the question is, what will the response time, transaction response time be for this application? So you focus on just that application, on certainly the other ones that can interfere with it, the configuration it's running on, and focus on answering response time problems.
Okay.
Not necessarily finding bottlenecks and optimizing, but just focus on what you're asked to focus on. Don't overdo it.
Okay. Thank you. Mike, by the way, you mentioned problem related to application response time prediction.
Right.
Okay. But people do modeling in order to make some sort of decisions. Can you explain your opinion how models help to make specific capacity management decisions? So we take applications, we model the response time, we know what to expect. So what? This is the end?
No, you're right. There's a more important reason to model, because you can get any response time you want. Just plug in more money. Okay, and this has always been, customers have always come up with saying, well, the response time's not good enough. Well, this is a negotiation, is what it is. So the question is, how can you get the response time you want and spend as little as possible doing it? So the modeling should help you decide what is the proper configuration. And in many cases, you over-configure.
Okay. You
have a solution that's way too expensive.
Okay.
So the real purpose of modeling is to optimize your resources and deliver that response time.
Okay.
Because you could always just pump more money in and buy more stuff. You'll get any response time you want.
So what you're saying that models help to justify what you have to do in terms of configuration to support your business needs, yeah?
Yes.
That's what you're saying. Okay.
And the other side of that is to anticipate if the workload is going to change, if 25% more transactions are showing up, you don't want to lose customers because response time goes through the roof and disincentivizes, if that's a word, these people from using that software and maybe going somewhere else.
Okay. And when we talk with customers, people using models, they're thinking, look, hardware becoming cheaper, very cheap. And software frequently free of charge. People use open source software.
Right.
But any modeling requires some efforts, time, resources. Okay. So how to justify role of efforts and resources we have to spend on modeling. Okay, and what, in other words, what is the return on investment in modeling from your point of view?
Well, I think that today your business leaders of an enterprise appreciate the modeling even more than before, and I'll tell you why. Way back in the old days, they were okay with 10-second response time. Remember, they used to say 10 seconds is good enough. And I think this is the golden age for modeling, because now there's this push to have sub-second response time. And for the business leaders of the enterprise, it's all about, can we convince people to continue to, let's say, use our website? Or will it get so slow that they'll jump off of it and go buy somewhere else? So that's really the monetary value of spending the time and money to optimize your system and deliver the response time that you think you need. You don't want to overdo it, but I think this is a great time for doing that, as opposed to 10 or 15 years ago.
Okay. But still, if somebody is thinking about convincing management, it makes sense to buy a modeling package and maybe develop modeling from scratch. And I think it will be valuable for my company, but how to justify and show some sort of return on investment in modeling? Any thoughts?
It's risk. You know, that's all I can think of. Is it's really, why would you invest a lot of money in redundancy if you've never had a failure? It's risk. You want to minimize your risk.
Okay.
So if performance is, in some ways, it's a kind of availability, although it's measured in seconds, not in hours before failures or days before failures.
So reducing risk.
Yes.
Okay. How to convert in money?
Same way that you do it for availability. That's sort of why I suggested that. They've come up with value with the cost of being down for an hour, for example.
Okay.
So whatever that is.
Okay.
What's the cost of losing customers?
Okay. Okay.
All right.
Okay. Thanks. Okay.
That's a hard one.
Yes. Yeah. So if somebody just starting their career and think that modeling can help to develop practical recommendations, justify decisions, okay, what are your recommendations? What we should start with? What would be the first couple steps?
Okay, a couple things. If you're modeling a system that exists, you know, sometimes it's hard to do this, but it's best to make sure that if there are any anomalies in the system, if it's not engineered properly, if there are unusual bottlenecks, they got to be straightened out first, because you can't model that sort of erratic behavior, and you can't then validate the model because things are just plain wrong. So it'd be good to get the system stable. So let's start with that. The second part is to understand what answer you're looking for. You're not going on an exploratory search. Make sure it's very clear what the requirements are. What are the answers you're trying to get? Is it response time for a single application, or is it something else? And so once you understand what the requirements for the model are, then I suggest be very open-minded as far as the tools. Don't fall in love with the tool. Use different tools, use the best, you know, do some research, use the best tool for that problem. Not to build some general model for the enterprise. Focus on the problem, find the tools. And then the third thing I suggest is when you're finished with the model, don't hesitate to throw it away. Move on. Okay? That's another reason why you don't build a general purpose model. Don't fall in love with your model. That is a pitfall that I was warned about when I first started modeling. And I ignored it. And I have some lumps out of that, you know, over the years.
Mike, what is your feelings? So to these days, even at this conference, we're talking about different phases of application development cycle. So a certain presentation at CMG talk about performance engineering. So what should be done, how to apply modeling and different technology on the stage of application development. Then people talk about DevOps.
Yes.
How to apply modeling during the DevOps process. Then how to apply modeling for performance management, finding bottlenecks and maybe evaluating different options and making decisions what should be tuned. Then we talk about capacity planning, making decisions about hardware, software parameters. So what are your feelings? Where models are more successful, and what are your recommendations in terms of applying modeling during application lifecycle?
That's a big question. Okay, so I think the role of a modeler during the development cycle is to take the input, to ask a lot of questions so that they have the right parameters, understand the configuration, understand what the performance requirements are, and do the best they can to build as simple a model as they can to just guess what the response time of the application will be, because let's say it's not built yet. Okay, I had an experience, so let me tell you an experience. I was asked to develop a performance model of the Iridium network. Do you remember that? Motorola headed up. I mean, this is old stuff. This is for satellite, instead of cellular phones, they were satellite-driven phones.
Okay.
And so the specific problem was that you should be able to hit the on button. This is a while ago, before cellular phones. Hit the on button and be able to get a ringtone in like 10 seconds.
Okay.
That was the requirement. That's what we modeled. And at first, a whole other group had tried, and that didn't work because it needed to model. We needed to develop a simulation because it was a worldwide network. The analytics of doing that with a mathematical model were intractable. So we started collecting specific metrics out of benchmarks. How long does it take to do this routine? How long does it take to do that routine? Okay, what are the routines that are called when you push the button? And eventually, we came up with a simulation that showed there is no way you can do this in 10 seconds. And here's the bottleneck, right? So really focus on the most important, prioritize your problems, prioritize your questions, go for the high priority one, attack the big rocks before you get into the sand and the gravel and everything. As far as DevOps, you should always have a goal as to what is your key performance indicators, like 10-second response time or whatever it is. And the modeler doesn't have to do that, but the modeler should supervise how you can run that test automatically on the actual software. Okay. And that automation should follow from the very beginning of development all the way through DevOps. We developed, when I was working for Unisys, we developed an application that we were putting on Amazon, and someone developed it was all done using DevOps, so someone developed this automatic testing, and every time there was a new build, it ran the test. Every time. So every once in a while, the test would run, something was horribly wrong, and it got fixed. And then when it went to Amazon, because that's the last step, so we went to Amazon, so did the tests. And they provisioned thousands of VMs and did tests for scalability and all that. But when you talk about DevOps, you're really talking about automating, running the model.
I'm talking about automating running the model with objective to minimize risk that something will be wrong when application will be deployed.
And to flag it and to check it every time someone makes a change, every time that software gets updated. And it should be a simple enough model. It shouldn't take hours and days, otherwise you're defeating the whole thing.
Maybe another area is finding anomalies, root causes, where also machine learning algorithm can be used to identify significant increase of response time or CPU usage comparing with previous test.
Right, so really, if someone checks it in and the test gets automatically run when they test it in, you know what the root cause is. It's that recent release. If it was running perfectly.
Specifically what in this release? Which module? Because you can see...
Sometimes you have to do a little more analysis. But then there are tools to do that, specific tools.
Okay. And now, sooner or later applications is in production, and one of the goals of capacity management is to really support business needs of different line of business, different applications successfully. And frequently, applications use multiple systems, multiple subsystems. So today we can see multiple data centers, many different platforms within each data center, and one business transaction can access information from one system, then from another system.
Absolutely.
So what is the service level goal? From business point of view, important not only CPU utilization and I/O response time on one subsystem, it's important life cycle of transactions and end user experience, which is actually accessing multiple systems. So what are your thoughts about capacity management for distributed systems with multiple platforms where service level goals are related to business transaction, business response time?
Well, that's what I've been talking about, is business level transactions. Right. So you need to be able to measure that from beginning to end. There might be a whole mishmash in the middle, right? But what you're interested in is that. Right. And so that's what you should be testing all along.
Yes, but how to model this type of...
Okay, so how do you, so how do you model it? So you start with very big blocks again. So you have whole computer centers and then break that down into pods or modules, and just start with the very large pieces, all right? And to see how you're using it. Now there are tools today, and they're demonstrating them here, that trace an application, a transaction, through all those pieces.
It's a smart thing.
It traces it. So then, once you have a trace, you can see where the big service centers are.
Okay.
All right, and then you can also look. I believe they also provide the utilization of those service centers.
Okay.
So let's say you're getting the response time you want, which is a lot to assume. Let's say you are, and you know what all the utilizations are, and then you're not later. You can go back and see which ones change. But there are tools today that do this. But bear in mind, this is for J2EE type applications and all that, which is now becoming like the standard new applications that are being written. So our lives as modelers have gotten simpler. When we were back then, this was almost impossible, right? Because it was possible, but very expensive. You had to spend a lot of time researching and looking at it and doing all that stuff. But even back then, right, what you really want to do is identify what you think are the critical bottlenecks along the path of that transaction. And we used to do it, but it was time consuming and expensive. Now it's easier. Okay, and that includes the cloud. There's no difference really, because you can look at the utilization of your VMs in the cloud just like you can in your data center.
So if you build a model of data set with multiple systems, you build actually, are you talking about queue network models? You build to model each particular system?
Yeah.
Or are you talking about different type of model?
No. It's a queuing network model. It could be mathematical or simulation, either way.
Okay.
If you do it mathematically, chances are, with the assumptions that are in those modeling packages, you're probably going to over-configure it because you won't get as much queuing as they might predict. They all assume MM1 service centers.
Okay.
It's not necessarily that.
Okay.
All right? So you might over-configure, but at least you won't have a surprise and response time. It'll be better.
Okay.
But yeah, absolutely, it has to be queuing networks. Otherwise, you could just add it up with a calculator.
Okay, great. So Mike, based on rapid change in everywhere, cloud computing and big data and etc. Okay, what do you think? What is the future? What are the biggest challenges, opportunities in using modeling during the next 3-5 years?
I don't see any big challenges, to be honest, because it's the same stuff. I mean, we've been doing this for a long time. They haven't come up with some different kind of computer that we don't understand. They haven't come up with some
quantum computing.
Well, it's just it'll be faster. That's for us as modelers. It got faster. That's all. Right? Shorter service times. Big deal. But the whole nature of how it works with queues, for example, like you just said. That computing will always use queues unless they figure out a wormhole to another dimension or something. But if you're talking about the future of modeling, I think that
future role of modeling, yes.
So I don't see future challenges as much as I see future opportunities for modeling.
Okay.
Like I said, you have these new tools for all the new applications that are being built. So you can provide sub-second response time and you can measure it and all that stuff.
Right.
All of this new big data technology and analysis and everything helps us, right? Helps us go through more data quicker and identify the bottlenecks. I think that there are some opportunities for people who want to develop models based on these new transaction monitoring packages that they're talking about here, because they don't do modeling. They just tell you what it is, and they identify all the service centers and how busy they are. But if you fed that into a model and perhaps even use a little finesse and intelligence, the next step to me, I was thinking about this today, is to do perturbation analysis. So, okay, everything's going well now. What happens if you have a sudden spike of 20% more transactions a second? What breaks, right? Where's the bottleneck? So you could have a model that does that sort of thing, that does a what if, because it's all about response time. And like I said, today, it's more critical than it's ever been.
Good. So I can see that Mike is very optimistic, and we have more opportunities, more challenges, but more opportunities. We have very detailed information collected by different vendors doing monitoring,
right?
Okay, and risk of surprises is increasing because complexity is increasing.
Yes.
We work with interdependent world. Different components can affect performance of other components. So role of modeling, according to your opinion, will be increasing, and we'll have a great opportunity to apply our skills.
Yes, that's what I'm saying. Yes,
Mike.
absolutely, Boris.
Thank you very much, Mike. Thank you.
Okay.
Thank you.